Electric current properties. What is the importance of electric current? We use the electric current everywhere around us. We use the electric current in our houses. We use the electric current in streets. We use the electric current everywhere in our schools, in supermarkets. So we need the electric current and we need to generate the electric current. How is electric current generated? We already know that the nucleus of any atom contains the protons that are positively charged and surrounded by electrons that are negatively charged. In metallic atoms, these electrons are free electrons. So when we connect a wire with an electric source, the electrons begins to move in this wire, and the flow of these electrons from one end to the other causes the generation of electric current. So what is meant by electric current? Electric current is the flow of electric charges through the conductor. We have three properties that we have to measure about the electric current. The first one is the electric current intensity, and we can calculate the electric current intensity by using this rule. The current intensity equals the quantity of electric charges divided by the time in seconds. And the unit used to measure the electric current intensity is called ampere. We use the ammeter to measure the electric current intensity, and the ammeter must be placed in series. The unit used to measure the current intensity, as we said before, is called ampere. And what is meant by ampere, or define ampere? Ampere is the electric current intensity when a charge of 1 coulomb passes through a given cross-section of a conductor in 1 second. The ammeter has this symbol inside the electric circuit. It's capital letter A in a circle and is connected, as we said before, in series. Let's take an example. Calculate a charge of a current flows through a cross-sectional area of a wire in 10 minutes if the ammeter measures a current of 5 ampere. How can we solve this problem? At the first, the ammeter measures the current intensity, so I equals 5 ampere. Secondly, the time equals 10 minutes, so we must convert this time into seconds by multiplying 10 times 60. Let's see our solution. At the first, we write the rule Q, which is the charge, equals the current intensity I times the time in second. So 5 times 10 times 60, and this equals 3000 coulombs. So the charge of this current equals 3000 coulombs. The second property that we need to measure about the electric current is the electric potential. What is meant by electric potential? The electric potential is the state of an electric conductor that shows the transfer of electricity from it or to it when it's connected to another conductor. So, what is meant by the potential difference? The potential difference is the work done to transfer a charge of 1 coulomb between the two poles of the conductor. So, if we don't have any potential difference between the two poles, this means that there is no flow of electric current. So we must have high potential pole and low potential pole and when we connect between these two poles, the flow of electric currents take place from the high potential to the low potential. To understand the potential difference, the flow of electric currents as the flow of the water in this figure. The high level of water, such as the high potential, and the low level of water, such as the low potential. And the water always flows from the high level to the low level. And what will happen if the water level is the same? There is no flow of electric water. So the potential difference must be exist to have a flow of electric current, and when the potential difference equals 0, there is no flow of electric current. Alessandro Volta is the Italian physicist who discovered the electric current. And so we measure the potential difference by the unit taking his name, which is the volt, and also the instruments used to measure the electric current potential difference is called voltmeter. So we measure the potential difference between the 2 points of an circuit by connecting the voltmeter parallel to this circuit, and the unit used to measure the potential difference is called the volt. What is meant by volt? Volt is the work done to transfer a charge of one coulomb between the terminals of a conductor. When we need to move an electric charge from one terminal to the other, we must have a potential difference between these two terminals. The volt is the work done to transfer this charge between the terminals of the conductor. And the rule used to calculate the potential difference is V, which is the potential difference, equal W, which is the work done in joules, divided by Q, which is the charge of this electric current. EMF. What is meant by EMF? EMF is the electromotive force. The electromotive force is the potential difference between the two poles of the battery in an open circuit. What are the two poles of the battery? They are the positive pole and the negative pole. In order to have any source of electricity, we have two poles, positive and negative, and to allow this source to pump out the electric current, we need to have potential difference between these two poles. This potential difference is called the electromotive force of this battery. So any battery is like a pump of electrons. It pumps out the electric current, so it must have its electromotive force, which is the potential difference between the positive and negative of this battery. They provide a voltage difference to the circuit that this battery will connect it to. The types of the cells we used in our circuits are wet cells and dry cells. And the examples of wet cells and dry cells, the wet cell like the car battery, and the dry cell like this dry battery. They both are used to generate or to be a source of electric current. The last properties that we have to measure for the electric current is the resistance of the electric current. What is meant by the resistance of electric current? It's the opposition faces the electric current during its passing through a conductor. And there are two types of resistance. The first is the fixed resistance or the fixed resistor, and the second is the variable resistor. The fixed resistor is fixed in the circuit, while the variable resistor can change the resistance of the electric current. As we mentioned before, we have two types of electric resistor. The fixed resistor that is gives a fixed value of the resistance, as we mentioned before, and the second type is the variable resistance, and the variable resistance is called the rheostat. What is the construction of the rheostat? The rheostat consists of high resistance wire that is coiled around a porcelain cylinder and fixed in 2 points, and a slider that moves above the coil. This slider, when we move it, gives us a different length of the electric wire inside the electric circuit, and so we can change the electric resistance. We can change the electric resistance, and according to this change, there are two parameters will change. They are the electric current intensity and the potential difference between the terminals as well. Here are a figure of the circuit samples, and we need to learn these samples as we will need it to draw any electric circuit. The first sample is the cell. The long dash is the positive pole, and the short dash is the negative pole of the cell. And if we have many cells, this is called the battery of the circuit. The third shape is the switch, and this dash, when we put it down, so the circuit will be on, and when we move it up, the circuit will be off, and there is no electric current passes through the circuit. The voltmeter is capital V inside circle, and is connected, as we mentioned before, in parallel. And the ammeter is a capital A in a circle and is connected on series in the electric circuit. The resistor is a fixed resistance, and this is the shape of the resistor. The rheostat or the variable resistor takes the same shape with this arrow that considered to be the slider that used to change the value of the resistance inside a cell, and the last one for the electric lamp. Finally, we reach to the law that connected or combined between the three measurable properties that we have mentioned before. This rule is was put by Ohm, and it's called Ohm's law. Ohm used this electric circuit in which we have a battery as a source of electricity, a fixed resistance, and the voltmeter to measure the potential difference, a variable resistor or a rheostat, a key to make the circuit open and closed, and the ammeter that is connected in series in the circuit. Ohm begins by closing the circuit and take the reading of both the voltmeter and the ammeter for the potential difference and the current intensity. Then he changed the position of the slider to change the resistance inside his circuit, and take once more the values of the potential difference by taking the reading of the voltmeter and the value of the current intensity by taking the reading of the ammeter. He repeated these steps many times and found a relation between the potential difference and the current intensity. Potential difference equals the current intensity times a fixed value or a constant value, and this constant value equals to the fixed resistance in the electric circuit. So what is the statement of Ohm's law? Ohm's law statements is potential difference V across a resistor is proportional to the current intensity that flows through it at a constant temperature. And why we must mention the constant temperature? Because as we know, the electric current wires made of metals, and as we change the temperature it may expand or contract, so this will change all the three properties. So if we begin to connect a circuit like Ohm's law circuit, we must fix the temperature to take accurate readings of voltmeter and ammeter. We can represent the three parameters or the three properties that we can measure for the electric current according to Ohm's law by this triangle. From this triangle we can conclude three laws. If we want to calculate the potential difference between the terminals of the wire, so V equal the current intensity times the resistance, and if we want to calculate the resistance, so the resistance equal the potential difference V divided I, which is the current intensity. And if we need to calculate the current intensity, we will divide V over R. This figure gave an idea about how it works, how Ohm's law it works. It represents the resistance as a man that want to stop the flow of electric current, which is the ampere, and the potential difference, which is represented by the man called volt, push the electric current from one terminal to the other. Let's have some examples. Calculate the current through a 3 ohms resistor when a voltage of 12 volts is applied across it. Let's start. So we have R, which is equal 3 ohms, and the potential difference V, which is 12 volts, and we need to calculate the current intensity. So current intensity equals V divided R equals 12 divided 3 equals 4 amperes. And please don't forget to write the unit of the measurable parameter or the measurable property. So if we calculate the current intensity, we must write ampere at the end of the result, and if we calculate the potential difference, we must write the unit, which is the volt, and if we calculate the resistance, we must write the ohms beside the result. Another example. Calculate the electric current intensity that flows through cross-section of a wire. If a charge of 10 coulombs passes through in 10 seconds. So we need to measure the current intensity. We have the Q, which is the charge of this current intensity, equals 10 coulombs, and we have also the time, which is 2 seconds. We will write at the first of our solution the rule that we will use, I equal Q divided T equals 10 divided 2, and the result will be 5 amperes. Another example, calculate the current intensity due to flow of 5,400 coulombs in 5 minutes through a conductor. So we need to calculate the intensity, and we have the Q, which is equal 5,400, and the time is 5 minutes. Don't forget to convert the time from minute to second before solving the problem. At the first, the time equals 5 times 60 to convert the time from minute to second. So we have 300 seconds as the time. Then we will write our rule, I equal Q divided T. 5,400 divided 300. And the result will be 18 amperes. And don't forget to write the unit for the measurable parameter or the measurable property that you are calculating. Another example, calculate the quantity of electricity that flows in a wire. So we have to calculate the Q. If the current intensity passing through it is 18 amperes, so I equal 18 amperes in a time of 7 minutes, and as we have seen before, that the time must be converted into seconds. Let's see our solution. The first step, converting the time from minute to seconds, so we have 420 seconds. The rule that we will use it, Q equal I times T. 18 times 420, so we have the quantity of the electricity equals 7,560 coulombs. Another example, calculate the work done to transfer a unit charge of 5 coulombs through a conductor if the potential difference between its terminals is 3 volts. Let's see how to solve this problem. At the first, we put our rule that work done equals potential difference times quantity of electric charges, W equal V times Q. So it equals 3 times 5, and the result will be in joules, 15 joules. Another example, if the work done to transfer a charge through a conductor is 150 joules, potential difference across its terminals is 3 volts. Calculate the current intensity passes in 10 seconds. So we have two parameters to calculate. Let's start. At the first, we will calculate the Q. Q equals the work done divided the potential difference equals 150 divided 3. So the Q, or the quantity of electric charges, equals 50 coulombs. Let's see the next step. To calculate the current intensity, we will have this rule, I equal Q divided T. So 50 coulombs divided the 10 seconds equals 5 amperes. So we need in this type of problems to calculate two parameters instead of one. What is the quantity of electricity which passes through a conductor? Its resistance 1000 ohm for 30 minutes. Don't forget to convert minutes to seconds. When the potential difference across its ends is 220 volts. Also, we have two parameters to calculate. At the first, we will calculate the electric current intensity by using the rule V divided R, 220 divided 1000, and the result will be 0.22 amperes. Secondly, we will use the second step, Q equals I times T, to calculate the quantity of electric charges, equals 0.22 times 30 times 60, that is equal 396 coulombs. Thank you for attending this lesson, and I'm waiting for your questions. Thank you a lot.